Okay, so we are going to simplify this complex fraction as a part of a review for pre-calculus. So if you recall from doing fractions in general, if we are adding or subtracting fractions, we need to get a common denominator. And the way we do that is to get equivalent fractions of each of these with the same denominator. How do we get common denominators? We make them, as I said, into equivalent fractions by finding the LCM, the least common multiple. And let's discuss what that is. So let's take the numerator of this whole thing, which is this box, which is 1/4 minus 2/5. And I'm going to get a common denominator for these. So these are small numbers, and it's pretty easy to do it. But the strategy to do this, if it's a larger number, or if you just don't know with a certain set of numbers, is you count by each of these numbers. This lowest common multiple is the number you get when you just start counting by a number. The first number that they have in common, that is the LCM. And so here we are going to count by 4s. 4, 8, 12, 16, 20. I'm going to stop there because I know that when I count by 5s, I hit 20 very soon. Now here in the 4s, I had to do it 5 times. So I had to count 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5 to get to that. And here I had to do it till 4. So 5 times 4 is 20, and 4 times 5 is 20. So in order to keep these equivalent fractions, I have to multiply by the same number on the numerator and the denominator. So since I'm needing 20 to be my denominator, I'm going to multiply this times 5 with this numerator as a 5 also to keep this as a form of 1. Minus 2/5. Here I want the denominator to end up being 20. So I'm going to multiply by 4, and 4, that keeps it 1. The reason I remind you of this and as a strategy for doing math with things you know and with smaller numbers, smaller examples, is because in harder ones, when these are polynomials, binomials, anything like this, you're not going to have just numbers here. You will have binomials or something, or just something more complex. But the strategy is the same. So if you go back and you look at what we are doing with just numbers like this, with no variables, no terms, no nothing like extra terms, I mean, besides constants, you can still see what you're going to be doing. Okay, so here these are forms of 1. Right? Okay, so let's do that math out. 5 times 1 is 5. 20 minus 8 times 20. Now that they have a common denominator, I can just add up their numerators. So 5 minus 8 is negative 3 over 20. Now, I cannot simplify this because 3 is a prime number, and when I count by 3s, I do not ever get to 20. I skip right over that. I go from 18 to 21. So that's as simplified as it can get. So negative 3 over 20. Now we take negative 3, or minus 1/3. Now, this doesn't have a fraction. So I was like, what do I do? But if you recall, anytime you want to make a fraction out of a whole number, you just put it over 1. So I have negative 3 minus 1/3. Again, I want a common denominator because I'm subtracting here. So 3 is going to be the denominator, because 3, because this is 1, I just multiply it by anything I want, and I get it. And 3 will automatically work there because, you know, I'm just going to multiply this by 3, and that's already 3. So I need to have this, of course, be an equivalent fraction. So I'm going to multiply the numerator and the denominator by 3. So this is a form of 1. Right, and then I'm going minus. I don't need to do anything to this because it is already the denominator I want. So now I have this, which is negative 9 times 3 over 3, with minus 1/3. Now I have my common denominator, so I just add up my numerator. So negative 9 minus 1 is negative 10 over 3. So I have this now. So each one of those is simplified and reduced as much as possible. Now I take this and divide it. So I'm going to take this and I'm going to write it in a way that we're used to seeing division written. So this is the same thing as writing negative 3/20 divided by negative 10/3. And this is where, if you recall from past math classes, our keep, change, flip idea comes in. We keep the first problem, the first term here, the same. We change this to multiplication and we flip this fraction over. Okay, now we just do the math. We simplify if possible, which is not here because we can't simplify up or down either way, and we can't simplify crossways. So if we could, we would do that, but since we can't, we're just going to multiply straight across now. Negative 3 times 3 is negative 9. 20 times negative 10 is negative 200. Now these are both negative, so negative divided by negative is a positive, so I'm just going to basically get rid of those negatives, and I have 9 over 200 as my final answer.